Inductors, capacitors, resistors. Which of these will delay voltage if placed in an AC circuit? Most people might fail trying to answer this. Let's talk briefly about how these components behave in an AC circuit. For inductors, every time current flows through an inductor, a magnetic field is generated around it, and the magnetic field changes. Whenever current flow changes, this magnetic field stores energy, which is absorbed from the motion of electrons. That's the current. So, the acceleration of the electrons is slowed initially, until a balance is gained by the magnetic field. This is why the inductor is set to resist change in current. Also, if current flow is reduced, the inductor releases energy from its storage, which slows down that change. Because of this, if a direct current is passed through an inductor, stays on a while, and is turned off, we have an exponential rise and decay of current flow through the inductor, signifying a delay in current rise and its collapse. As we can see, the green line represents the voltage from source, while the blue line shows the current flowing through the inductor. You can see the gradual rise of the current compared to the instantaneous rise of the voltage, because the current flow is initially slowed until the magnetic field is built. After that, the inductor acts as a short until there is another change, this time the disconnection of the voltage source, making the voltage drop to zero. And as the magnetic field collapses, the energy stored there keeps the current flowing till its complete but gradual collapse. If an alternating current is introduced, since we have an oscillating current flow, we see that we have a current that lags the voltage. Voltage and current are not in phase. The voltage leads to current by 90 degrees. Also, it is observed that alternating current magnitude varies with frequency. In other words, for inductors, there's a frequency-dependent opposition, or resistance to flow. The higher the frequency, the higher the resistance. And this resistance is called reactance. For inductors is referred to as inductive reactance, represented as XL equal to pi FL, where F represents the frequency, and L represents the inductance. For capacitors, it is said that capacitors resist change in voltage, because when voltage is changed across the capacitor, it responds by initially pulling in a large amount of current to charge up. We can see from 0 amps to 12 amps instantaneously. And this current pull reduces rapidly over time, as the capacitor gets fully charged. This causes a delay in voltage rise across the capacitor. The capacitor doesn't completely prevent voltage changes, it just slows it down. Now for AC, since it's a periodic sine wave, we'll notice the current leads the voltage, and it leads it by 90 degrees. Also, it is important to note that the magnitude of current flow also varies with frequency. The higher the frequency, the lower the resistance. Same kind of frequency-dependent opposition to current, as we saw with the inductor. And this is called capacitive reactance, and is represented as X equal to 1 over to pi Fc, where F represents frequency in hertz, C represents capacitance in farads. Unlike the inductor, capacitive reactance decreases with increasing frequency. These two properties, phase shift and reactance, help capacitors and inductors to be used for coupling and decoupling. Now, coupling capacitors block DC and pass only AC. XC, which is the capacitive reactance, is highest at F equal to 0 Hz. Decoupling capacitors transmit high-frequency noise to ground. They can also be used as filters, and we have high-pass filters, blocking low frequencies and passing high frequencies. And we have low-pass filters, where we have inductors used to block high frequencies, but pass low frequencies. For the high-pass filters, we have capacitors that block low frequencies and pass high frequencies. Then it also helps them to be used in power factor correction. So capacitors are used to cancel the lagging current of inductive loads, reducing reactive power losses, while inductors are used to balance phase shift from capacitive loads by introducing an opposing lag to the current. They can also be used in transformers, transferring energy from one coil to another via induction, inducing voltage on it. Let's note that resistors in AC behave basically the same way they do in DC. Their voltage and current are in phase, and their resistance isn't dependent on frequency. Please like, comment, share and subscribe if this was helpful to you.